worse than putting it in and having to take it back out. Anyways, John Pickles.
All right. Thank you, Ross. Thanks for the invitation. It's always a pleasure to come and talk about a topic that I'm quite interested in, noise control. So what I'm going to do is talk to you a little bit about what noise is, what the noise bylaws are, and a few tips on things that you can think about when you're installing air conditioning units. So we'll start off with, I guess, what is the scale of the problem. And this chart just shows us, over the last few years, the number of noise complaints that a typical municipality could receive. This is from my colleagues that work out of the Richmond office. This is from Richmond. On this side, we've got a number of complaints for each particular type of noise complaint. And then on this side, this is the total number of complaints, and that's the red one there. So air conditioning units would fit into the mechanical category. So would lots of other pieces of equipment, so sorts of pumps and other sort types of that type of equipment. Now, I can't give you an explanation as to what happened in 2009. There was a bit of a blip there where they got a lot of complaints for the type of equipment in Richmond. But typically we're looking at probably somewhere around about 30 complaints a year, compared to around about maybe 240 total complaints. Construction is the main category of complaint that they're receiving in Richmond. It's probably very similar actually to the North Shore. So we're looking at maybe a quarter of complaints are to do with mechanical. All that is not going to be air conditioning. Toronto did a similar study, and they attributed 15% of their complaints purely to air conditioning units. So that's the sort of scale. I'm not saying that all those units were incorrectly installed, because sometimes we'll go and there isn't a problem, even though somebody's complaining about it. But that's where the complaints are running at. So maybe very quickly, just to go through what sound is. Sound is a mechanical wave. It's an oscillation of pressure in a medium. The medium we're in is air, but it could be water, it could be a solid. Sound has an amplitude. Colloquially, we'll call that loudness. It'll have a frequency, which we usually call a pitch. And everybody, I think, has the same experience that as we move away from a sound source, the further away that we move, the sound level generally drops, gets quieter. So that's the sort of physics of it. Yes?
Is that linear or exponential?
So we'll get onto that a little bit further later on. It is. Let's get on to it later on, maybe. Okay. So, if we can think of air particles, or we think of the air as particles, and they're sort of oscillating around a central point, and there's some distance between each of these particles. So, the particles are sort of represented by the dots in this tube. So we have a very long tube. We have a piston at one end, and what we're going to do is we're just going to move the piston. And that sort of pressurizes the air that's touching the piston. That energy is then transferred to the neighboring particles. And so these particles that are being pushed, and you've got an increase in pressure where you have the stronger line. Those particles then move back to their normal place, but they've imparted the pressure to the next air molecules next to them. And so that this pressure wave moves away from the source towards, if you had an ear here, to the receiver. It will move at a constant speed, which is the speed of sound, which is 344 meters per second. So after 1 second, it's 344 meters away. if you had your ear here, you'd probably maybe not quite call it sound, but you would sense something when suddenly this pressure got to your ear. Ordinarily, things are vibrating backwards and forwards. So if on this one we've got a wheel that is giving rotational force through the can, it's going to be backwards and forwards motion. So if this wheel is doing 1 revolution in 1 second, it's 1 cycle per second, 1 hertz, okay, and the pressures are moving away at a regular distance between each other, and that distance is a wavelength. If we speed the wheel up so that we're doing 2 cycles per second, so we're now doing 2 hertz, these lines would move closer together, so you'd have lots of lines in between, or a long line in between there, so the spacing would come down by half. So the frequency and the wavelength are related inversely. Okay. So the sorts of equipment that we're installing can create vibrations which can be transmitted to the air, and so the different sorts of components that are going to be found in the air conditioning units that can cause these vibrations. Well, there's the fan itself, which is going to move the air, but not only the fan blades, which typically the sounds produced by the fan blades will have a particular tone, and usually that tone is dictated by the rotational speed of the fan and the number of fan blades. Not only are we getting the sound from those fans, but also there's the electric motor that has a casing, and that's vibrating, so that casing vibrating will vibrate the air that's surrounding that, and that will create noise. In the same way for the compressor, the internal parts in there, so you've probably got valves and a motor. I don't know exactly how it's inside a seal case. Well, I know there could be elves in there and everything happens by magic. It's this time of year, Christmas. You guys can tell me more about that, but basically the case vibrates, and that's going to vibrate the air that's surrounding it, and that's going to create noise. Air turbulence, fans inside, ducting. Usually as the air is moving in the ducting, you will get turbulence noise. In your outdoor units of air conditioning units, maybe not as much, unless you've got maybe a snow guard or something where it's going to create turbulence in there. And then finally the actual equipment casing, the outer casing. If you don't have the properly installed isolation mount on your fan or on the compressor, then those vibrations could then get transmitted to the casing, and then the casing can vibrate and become a sounding board to create the noise. Same way with the isolation mounts that are on the base. If you've got it hard fixed to a concrete base or flags, then that vibration can transmit through, and then that becomes a big sounding board and create noise. Okay. So, the air pressures that are transmitting through the air come to the ear. The eardrum moves through the mechanical parts of the ear to the cochlea, sends an nerve message to the brain, and we interpret that as sound. The human ear is quite remarkable. We can detect infinitesimally small amounts of pressure. That's 0.002 of a pascal, up to 20 pascals. So the range is about 1 million. So that's a huge range. Certainly more than we can fit on a linear scale. Trying to have 1 million graduations is mind-blowing. Also, the way that the brain interprets the signals from the ear is such that actually we don't detect change in sound very well. So the sound pressure has to double roughly before we can actually hear a sound, which is a more logarithmic, it's more of a logarithmic change that we're sensing rather than linear. So that's why we use decibels, because the bell is just a simple engineering term to compare a value with a reference value and take the logarithm of it. So we're going to condense the scale. The reference value we use is the threshold of hearing, which is a very low value. So from the threshold being 0 to the top end, which is the threshold of pain, and we've now gone from 1 million down to 120. So it's a lot easier for your equipment, it's a lot easier for us to comprehend, and it's as representative as the human ear works. Okay. So now we're dealing in a logarithmic scale. Math doesn't work as normal. So a doubling of sound energy, so we have two sources, we can switch them on independently. So we have a source that's at 50 decibels and a second source that's at 50 decibels. Turn them both on at the same time. 50 plus 50 doesn't equal 100. 50 plus 50 equals 53. Changes in decibels and how we respond to those changes. 1 decibel, can't even tell the difference. I can measure it on my sound level meter, but nobody can hear it. So it's important when we're doing any remedial action, particularly there's a lot of sound blankets that are marketed for noise reduction. In my experience, I don't know that I've seen all of them, but in my experience, a lot of the sound blankets that are marketed to just put on the inside of the casing, probably going to give you a reduction of 1 decibel, maybe 2 decibels at best. So you're spending money on something that people are not going to be able to hear the difference. So 3 decibel difference, just about perceptible. So we had 2 sound sources in this room, maybe 50% of you say, oh, you know, I can tell the difference between that if we turn one on and then the other one on. Some in the room say, no, I can't tell any difference. Some would say, you know, yeah, definitely. Once we get to a 6 decibel difference, pretty much guaranteed everybody in the room is going to say, yeah, hey, that's different. We have 10 decibel difference, people will recognise that as about twice as loud, and 20 is going to be 4 times as loud. So we're going to talk about the pitch. The human ear can hear a wide range. Low frequencies 20 Hertz up to 20,000 Hertz. Keyboard here, so 20 Hertz is here down at the low A. Here we've got about 4,500 top C there. So the piano scale isn't quite as broad as the human ear. The human ear can hear a lot higher frequencies than the piano can go up to. So that just gives you an idea for a frequency. We can't hear frequencies with the same ability. This is a chart called equal loudness. This was done with students in the 50s. They were exposed to different sounds of different frequencies and different loudness, and they were asked to say which sounds sounded about the same. And these are called phon lines, and what you can see from this is that we seem to hear frequencies around 1,000 to 4,000 really well. Those are commonly the speech frequencies, so that's why we hear them really well. Anything sort of above 8,000 we don't hear as well. So what we're saying on these curves is anything that's on this line appears to the listener to be about the same level. So we don't hear low frequencies very well either. The sound level meter hears all frequencies in the same way. The reason why we do an A weighting, we were talking earlier about the A weighting, is that the A weighting is basically the inverse of this curve at about 60 hertz. On that curve, it's the inverse of that, so that it converts what the sound level meter reads to be more representative of what we hear. So there's the good thing is it's more representative about what we hear, about what we hear, but sometimes there are certain frequencies that we're exposed to that we're annoyed by, but the A weighting doesn't necessarily show that up. That's if it's sort of in here or in here. Okay. Well, what I will say is for the air conditioning units, most commonly we'll have frequencies probably somewhere in that band, the 250 to the 500 hertz, are often commonly frequencies where we can get a little bit of a total content. And it's usually a function of the number of fan blades and the speed that the fan's going around. So, noise really is no different to sound. There's no two different things. Sound is noise, but it's just the way that we think about it. Noise is commonly thought of as unwanted sound. The bylaws generally across the province do define noise, and most of them you seem to use the similar sort of wording. So it's sound that disturbs or tends to disturb peace, quiet, rest, enjoyment, comfort, or convenience of, and then in brackets it's because all the different variations of the different municipalities. So some will say of persons in the neighbourhood, or some will say of any person in the neighbourhood, or any persons in the neighbourhood, or they could use neighbourhood or vicinity, or both. So generally that sort of wording is what we use. So what does that mean? What is disturbing? These are the sort of the factors that I would look at. These are the factors that courts have considered when they're deciding what is disturbing. So there is the loudness. The louder the sound is, the more likely it is to be disturbing. There's the temporal quality. So how does that sound vary over time? So some sounds are pretty constant. So we'll look at road noise from a distance. So you may be quite some distance, say a kilometre or more away from a busy highway. Those sounds are pretty constant. We tend to adapt to those quite well, and we find those sorts of noises less disturbing. Then we've got sounds that are intermittent. So they're on, and then they're off, and then they're on, and then they're off. Probably typically an air conditioning unit setup. Those type of sounds we find more annoying, and part of that is probably the sort of fight or flight. It's a sudden onset, and we're constantly frightened by that, particularly if it's happening at night. Impulsiveness is a part of a temporal pattern. Impulsive sound is bangs, crashes, so they're very intense sounds with a very short duration, so maybe less than a second. Those we find extremely annoying. Sounds with a tonal content, again, are usually found extremely annoying. And that, to best describe that, would be if you were to take the frequency in each of these bands and look at the sound level of each frequency. If you have 1/3 octave that is markedly higher, and we're probably looking at 5 to 8 decibels higher than its neighbours, its immediate neighbours on either side, then that sound has a tonal content. If it has a tonal content, we find that extremely annoying. Time of day is important. Nighttime is more sensitive to daytime, so you've got to be more careful in the quieter sounds at night. Also, non-acoustical properties are also important, such as the social setting, what's the neighbourhood like. If it's a heavy industrial neighbourhood, then the community usually expects more noise, so there's not as many problems. If it's a more rural setting and the noise levels are a lot quieter, then that's more of a problem because, you know, the sound levels you have to be quieter to be matching what the neighbourhood is. So let's have a look at quickly the bylaws, and there's different types of bylaws across the whole province. And so I'm not going to really look at individual bylaws in too much detail. Safe to say that we're going to go through the different sort of broad different types. So there are two main types of noise control bylaw. One type is where the bylaw sets specific noise levels that should not be exceeded. And then there are general prohibitions. And the wordings are that we went back. Sounds that disturb or tend to disturb peace, quiet, rest, enjoyment, comfort, and convenience. Anything that's like that is prohibited. So that's just a general clause. So those are the two broad categories. Those bylaws that set noise limits can be further divided into two further categories. So where we have values that are slightly different depending on the setting, or we have an adjustment. So if the sound has a particularly annoying quality, so we have the impulsiveness, or we have a tonal content, then they add a weighting to the sound and a penalty. So you might take a noise measurement, but if it has that content, you'll add a penalty to that, and it makes the noise level even higher, and then you're going to compare it to the binaural level. So let me pull out a couple of bylaws that I brought with me, so that we can maybe just dig into that a little bit more. So an example of the first set of bylaws which describe a value, but there's just one value. I'll give the North Shore and the City of North Vancouver as an example. So their bylaw says if you're in a residential area, at night time we should not exceed 45 decibels. Okay, so we have, and that is at the place where the noise is received. So not at the source, so not where you're installing the piece of equipment, but where the complainant is. And it can be anywhere on the complainant's property. In the City of North Van, they describe the point of reception where the measurement must be taken as anywhere over the property line. Generally, I will look at a location where there's the most disturbance. So if it's at night time and we're looking at people being disturbed by sleep, then we're going to be looking at somewhere in the vicinity of the bedroom windows. facade. If it's during the daytime that people are disturbed, then we're probably going to look at the patio or their outdoor recreational area. I generally don't do it at the property line. I have heard that sometimes people do take a measurement right on the property line. Generally not. City of Vancouver's bylaw does say that that's the preferential place for their bylaw, is to do it at the property line with the city property. Unless there isn't a street or a back lane, then they say it can be any location in the complainant's property. Because daytime and nighttime, there's different sensitivities. There are different values usually for daytime and nighttime. Daytime is usually higher, and then in the city of Melbourne it's 55. During the daytime, 45 at night. Bylaws can be described continuous sound, non-continuous sound. When they describe that, pretty much there's uniformity across all the different bylaws. Continuous sound is any sound that lasts 3 minutes or more in a 15-minute period, or any aggregation of 3 minutes in a 15-minute period. So you can have something that's on for 2 minutes, off for 10 minutes, on again for 2 minutes, and that will be more than 3 minutes in a 15-minute period, so that will be continuous sound. It's important to know that most equipment is probably going to be operating as continuous sound, even though you might think it's non-continuous because it's on and then off and on and then off, but it's unlikely that it means the non-continuous sound, which is less than 3 minutes in any 15-minute period.
Can it be impulsive and continuous at the same blend for the same?
Unlikely, because an impulsive sound has to be less than a second. But if you have a clank or a bang, so there's some malfunction in the equipment that gives you a clank or a bang, then that might be impulsive, yes. Okay. So,
John, can I just back you up a second?
yeah,
When you test the property line, or Vancouver does,
yes.
where the property line, height-wise, side of the house,
Okay,
side of the house?
sorry, right, okay. So, you're going to try and reduce reflections. So if I take a noise measurement, the biggest reflector is the ground. So you're going to be a fixed distance above the ground. So you're going to be 4 feet, 1.2 meters above the ground. I haven't got it with me because I've got so much other gear. But I usually have a tripod that's specifically set up so that it's at 1.2. But actually, if you hold it at arm's length, yeah, you're close enough to 4 feet. You're going to hold it away from you. Again, you're going to try and be as far away from reflective surfaces as you can. So if you've got a wall of the building itself, the home or whatever it is, again, you're going to try and be at least 4 feet away. If you can get further away, even better. So the ideal is to try and be 3 meters away from a facade. But there's lots of places where I measure, I can't physically get 3 meters away. So I'm going to be at least 1.2 meters away. I can't go any closer than that because you're going to get reflection, which is going to interfere with the reading that you're taking. Although the sound level meter doesn't measure well when the sound's coming from this side, but we've got pretty good coverage around. So ideally, you don't want reflection. So we're probably looking in those bylaws. If you meet the definition of continuous, which I'm suggesting that most equipment I've observed always meets continuous, and it's operating at night, and you've got to get it below 45. some of the bylaws, and the City of Vancouver, the City of Victoria, the City of Richmond are this type, they do set slightly different levels depending on what the different land uses of neighbouring areas may be. So if you're residential, which probably most equipment you're installing is going to be residential, it's still going to be the 45. But say you're residential and commercial, and they have a definition, and each bylaw will define that, then if I look at this City of Vancouver's, they allow a slight variation. And they say if you are so I have this flag a minute ago.
Generally, though, it's probably higher, right?
It's usually about 5 decibels higher. So if you're going from, so if your source is intermediate and your receiver is it can be 5 decibels higher, yeah, generally. But it's important that you look at the specific bylaw because they're all slightly different. And then lastly, the City of Victoria's and the City of Richmond have these extra weightings. So you'll measure the sound. If it has an impulsive content or it has a total content, then you're going to add a penalty of 5 decibels to the measured reading. And then you're going to compare it to the bylaw limit. Okay. Now, if you have the general prohibition, then that's going to be down to the person, the decision maker, who's going to, the bylaw inspector that's going there. They may or may not take noise readings. It will be their opinion. If in their opinion it's disturbing, it's disturbing. If they don't find it disturbing, it won't be disturbing.
That's disturbing.
Yeah, it's disturbing.
So, I mean, if I was in that position, I would take noise readings. I would probably try and compare it to some of these standards that we've been talking about. I can't speak for others.
What about like our scenario that we have in North Van, that you take a noise reading outside and you got highway noise and everything else,
Yeah.
which is basically over 55 dB right there.
Yeah.
And then you turn an air conditioner on, which is typically at 45.
Yeah.
How does that add together?
Okay. So I will always take 2 noise readings whenever I take a measurement, and that's the correct way to do it. So you'll take a noise reading in the same location, one with the sound of the complainant sound, the sound source that people are complaining about is the air conditioning unit switched on. I'll take a reading. That reading will probably be anything around about 3 to 5 minutes, generally. I'm going to do a minimum of 3 minutes because I have to prove it's continuous sound. Alright, so I'm going to take 3 minutes. Might take 5 minutes. Then I'm going to wait till the unit switches off. I'm going to stay in the same location to try and keep all the other variables. And it's going to be at the same time, so keep all the other variables the same. And then I'm going to take a second reading. And then I'm going to compare those 2 readings. And the second reading without this air conditioning happening is called a neighbourhood residual. And if the difference between those 2 readings is greater than 10 decibels, then the neighbourhood is contributing nothing to that first reading. And I know 100% that the first reading that I took is solely the source. Okay? If the difference is 9, 7, 8, 5, up to 3 decibel difference, then the first reading I took is not just the source, but it's the source and there's a slight contribution of the neighbourhood sound. And I will make an adjustment, and depending, I have a sliding scale, and I haven't just made that up, there's an actual scale that everybody's worked out over the years. And so I will take a correction factor away from the measured sound that is just the source, and it will be lower. So if I'm at round about 8 decibel difference, I'll probably take 3/4 of a decibel off. As I get closer, so maybe the difference is only 4 decibels, then I'm going to be taking 2, maybe 2.5 off. Okay, depends on which protocol you're going to look at. Okay, so there's a little bit, it's more than one protocol, and there's a slight difference. Okay, if the difference between the two is less than 3 decibels, then I can't tell you what the source value is, and I can't calculate that. It's basically, they're too close. I can't separate the source sound or the residual sound. Okay, and the residual sound, the source sound could be a little bit below the residual, or it could be a long way below, and I really can't tell. So in those circumstances, I would either go back when the neighbourhood was quieter, if the equipment was being used at that time. So I might go during the daytime, say, and the neighbourhood is higher than the source, and I can't measure it. But we know the equipment operates at night. So actually tonight, after I've been here, I'm actually going out taking noise readings at midnight. And that's because in the location where I have to take readings, the neighbourhood doesn't quieten down until that time of night. So then I will take a reading. But this equipment's operating 24 hours a day. So I'll take a reading then. And I did a couple of weeks ago. And there was 10 decibel difference. So during the daytime I could hardly measure a difference. But at 1:30 in the morning, there was more than a 10 decibel difference between the source sound and the neighbourhood residual. So I knew that the reading I take was the source, 100%, nothing else. Okay?
Yep.
Does that help?
That helps.
Okay. Common law nuisance. Nuisance has a place. So this is where one landowner might sue a neighbour. And this is where it has to be property owners, and it's dispute between one owner saying that you're interfering with my lawful enjoyment of my property because you've set up this noisy equipment and I can't use my property like I normally do. You go to the Supreme Court. It's nothing to do with the municipalities. This is just rights of individuals. But what's interesting is there is a court case very recent in 2009. It was about 2 neighbours that were here in Coquitlam. That's why I picked it up. It was an air conditioning unit. The neighbour didn't like it. I believe the municipality looked at the issue and decided it wasn't a breach of bylaw. The neighbours still didn't like it, so they decided to get a lawyer and they went to court. The judge looked at the situation. Noise measurements were taken. The noise measurements were that it was 50 decibels at night. The judge said, well, that's unacceptable. Even though the local bylaw doesn't actually define a noise level, there's lots of bylaws out there that do, in Toronto and in BC. Those were the ones that they looked at. The equipment breached that, so they said, yeah, it's going to cause a nuisance. So you've got to make it quieter, so that's what they ordered, or ordered it not used until it's made quieter. The 2 people that had complained got damages, and the legal costs were $100,000. So there may be other implications, not just bylaw. And the courts, when they're looking at we go back to this wording that's often seen in bylaws, that's common law nuisance. That's common law nuisance. Common law nuisance says if it disturbs the, I think it's disturbing the quiet enjoyment and comfort of your property is what's in common law. So it's very similar wording to what's in the bylaw. So that's potentially the problems, okay, that you can come across, how the bylaws may apply to you, or how somebody might go to court. So what can you do? What can you do? So the main thing is know how much noise your equipment's going to produce. Once you know that, you can start planning about where you're going to put the equipment. So the manufacturers should declare a sound power level. Some of them call it sound rating. There is a standard. There's the, I think is it AHRI now? It's slightly changed. I think it's an American standard. 270, which describes how to measure the sound emission from your air conditioning unit. This is for smaller units, I believe. There's the bigger commercial ones is a different standard. Russ was telling me over lunch that there's a very nice lab down in the US that you've seen.
Over our manufacturers in
Yeah.
the States, yes.
Yeah.
Dallas, Texas.
Okay, and they'll come up with some values. They'll give you maybe some values in the A-weighted, and they'll always give you an overall, which is sound power. So on that particular machine, it was 75. Generally these days, and they might also call it a bell rather than a decibel, but it's just one decimal place out. It's the same thing. Excuse me. Some of the older equipment could be a lot noisier than that, but I think generally now the manufacturing standard is, for these smaller units, is to try and be below 76 decibels. I don't know, you guys might tell me different.
I'd also say ARI standard 270 does have total penalties factored into it.
Okay.
That standard does include total penalties for air conditioners in that
Yes.
frequency.
Good. So that's built into the overall. That's the way that it's done, yeah. Okay, so once you know that, then the biggest factor for reducing sound is to get distance between the source and the receiver. The more distance you can get between, the quieter it's going to be when it gets to the receiver. It's very predictable. Sound travels in all directions, okay, spherically. And so we've got the sound power because the manufacturer is telling us what the sound power is, and so you can have this formula and plug in the values. So if we want to know what the sound level will be at 3 meters from having a unit that has a power rating of 75, we just plug in the numbers and do the math, and it would come out to be 7.5. Okay. If we wanted to know what it was at 6 meters, plug in the different numbers and it comes out at 51.5. What you'll notice is we've doubled the distance. We've gone from 3 meters to 5 meters. So you get a 6 dB reduction. And that's the same every time you double. So every time you double, you get a 6 dB reduction. So it means over a shorter distance, you get a reduction quite quickly because you're doubling shorter distances. But then to get the next 6 dB reduction, we've got to double 6 to 12, and then we've got to double 12 to 24. So progressively, as further away, it's not as good reduction. Yep. The problem is that we're not in the middle of a field and going out in a perfect sphere. We may have hard surfaces like walls that are going to reflect. So if we have a unit and we have a reflective surface within 3 meters, we'll get all the sound that would go in one direction actually coming back towards us. Now remember when we said we added decibels together, we have 50 plus 50 is 53. So if we notice that our value here, if we have one reflective surface, we're at 60.5. But say we put it in the corner, So we now got 2 reflective surfaces. We're going to add another 3. So every reflective surface, so the ground is a reflective surface, but the formula that we had for propagation hemispherically already takes into account the ground reflection. Once you have one wall, add another 3. Once you add another wall, and you're within 3 metres, you're going to add another 3. Okay? So that's not so good. Sometimes we might think we want to put a barrier in between the sound source and the receiver. That can help. It can help. Here we've got a sound source, we've got the receiver here, we've got our wall. The wall can help if it's very close to the source, or it could help if it's really close to the receiver, but then nobody wants a wall straight in front of your window. What happens is the sound radiates in all directions, gets to the wall, some of it's reflected back. The wall then becomes a secondary source and everything radiates out from a ball from this point, the leading edge of the wall. So you'll have a shadow zone here, and it'd be really good there, less good here. This chart, I don't expect you to look at it, but the chart too much, but the chart just tells you if you draw a straight line from the source to the top of the wall, from the wall to your receiver, you'll get an angle theta there. The bigger that angle is, basically the better performer it is in sound reduction. So here, because they're high up and they're looking over the top of the wall, this is not operating as well as if we had the people that are down here. So the angle now is much wider. So it's protecting these guys much better because they're going to be higher up here. So here is not much attenuation, here is lots of attenuation. So you want to be as high up there as you can. It is frequency dependent, so if you have high frequencies, walls work much better because the wall looks pretty big to high frequencies, because high frequencies have a small wavelength. So if you're really, really tiny, this wall looks massive. If you have a low frequency, which has a huge wavelength, then that wall looks pretty puny and doesn't work very well. Okay?
On the upper levels highway, there's a bunch of concrete fences.
Yeah.
Are they good design?
Well, they're pretty close to the source, and the first line of receivers are pretty close behind the wall, so it probably works pretty well for them. Maybe people that are set further back, maybe not as well.
Does the construction of the wall itself matter much if you put a hedge?
Well,
there?
you want massive, so you want heavy, and you want continuous, so you don't want any gaps in it.
Sure.
Hedges and that sort of thing, people think that they work wonderfully. They don't from an acoustic point of view. Psychologically, they may work wonderfully. You know, I can't see it anymore, therefore I can't hear it. But from an acoustic point of view, you know, there's lots of gaps and, yeah, no. Okay. People tell me all the time that it works really well, and I know some people have done development and put lots of property in and all of this, and it's wonderful. It's wonderful. So placebos work really well. Okay. Your other option is an acoustic enclosure. I mean, this is an example. This is an example out of Ontario's Ministry of Environment. I haven't made this up. I got that from those guys. They have a really useful guide. If you're going to have something like this, you're probably going to have to get somebody to help design it for you. I mean, the main feature is that any of the structure's got to be massive. You're going to have lots of fluffy material for absorption inside here. You've got to seal it well, but still allow your air to come in. So, where your air's coming in, you're going to have absorption material, and the length of this and the amount of absorption material is going to have to be designed so the sound can't get out. touching here, you need a good seal, but you don't want vibration flanking to come through, so you probably want some sort of anti-vibration membrane, but you do want it well sealed so that the sound can't get out. And then of course the sound is coming up here, but you build the length of this to suitably absorb it. So I think you're looking at probably lengthwise at least 2 times the wavelength of the sound that you're trying to deal with, at least. But you're better off getting an acoustic consultant to design it for you. I'm not going to design it for you. All right.
Or select a quieter model.
Quite a model. And the other thing I would say is that most of these are probably, the best you're going to get is probably about 10 dB difference, probably. You might get a little bit higher, particularly if you're paying lots of money and you get it really well designed. But generally, they're about 10 decibel, okay? Just so you know, I guess for the amount of fluffy material, nice and soft and fluffy, nice and solid, you want this fluffy material to come at least beyond the 1/4 wavelength for it to work really well. Here we've got absorption coefficient, 1 up here, perfect, gets everything down here, not so good. Frequencies on here, low frequencies, high frequencies. This is your nice fluffy material that's quite thin. So it's really good for the high frequencies, not so good for the low frequencies. As you get thicker material, it gets a little bit better at some of the lower frequencies, okay? Because that's coming further out. Okay. All right. So those are the sorts of treatments that you can do. I would probably suggest the best thing is having nice and quiet. Yes?
Your light fluffy material has to allow air to pass through it. Can't be like for a lightweight closed cell foam.
I would say that it could, but not everything works. It does depend on the structure of it. And so, for the best advice, you're better going to an acoustic consultant that's dealing with these materials all the time to give you the best handle. I have seen... mineral insulation is generally what I see, but there are some other modern materials that are more solid but still open, but not as open as mineral fiber. So yeah, I would talk to an acoustic consultant. I know of 3 on the north, 3 in the lower mainland. I'm sure there's more. But I mean, there's Brownstrachan, there's BKL, there's Wakefield on the island, but there could be lots more out there. This is the guideline in Ontario from the Ministry of Environment. It's an old document, but still quite relevant. You can Google search the name. This is an older version because I'm not prepared to pay for the slightly newer version, and I'm just getting the free one off the internet. These are the don'ts. There's a page of things to do, and there's a page of things to don't do. So less than 15 feet between, and you've got a window here on the side that's not having the unit installed, and you've installed the unit here, don't do it. It's just going to cause lots of grief. Again, small city lot, close together, you've got 2 reflecting surfaces, and it's just going to reflect it straight onto their outdoor patio area. It'll cause you lots of grief, don't do it. This is the unit where it's been installed. You've installed it right on the property line, right next door to the outdoor patio area. You're going to get lots of complaints, don't do it. All right. There is a nice standard, the 275. You can predict what your installation is going to be before you install it. Does anybody use this? Okay. You can get this on the internet from the US standard. What you do is you will need to know information, distances primarily between where you're going to install the unit and the nearest property. So you're going to need to know that distance. So you might talk to your client, talk to the neighbours to get that. So their assessment is you start off with what is your sound power. They're going to install this unit within 1.5 metres of the homeowner's wall. We get reflection. So you're going to add an extra 3 towards the radiated unit, the sound power of the radiated unit. So that gives you another value here. Then you're going to do an assessment of, is there any shielding? Well, everything's open here. There's no barriers. There's no buildings in the way. So we're not going to use any factors there. At the property line and at the outdoor patio, those are outside readings. So we're not going to use a sound path factor. Here there is actually a bedroom window that's open. Okay. So we'll do a sound path factor of 10. If you have a window that's slightly open for ventilation purposes, generally the sound level inside, the sound that travels through, you get about a 10 decibel difference between the outside and the inside. If the window's closed, depending on the type of window that you've got, you may get a much reduced sound level inside. But you're not in control of that house. If it was your own client, maybe they're happy to always have the window closed. So you could maybe take the window factor, which could be 20, 25, maybe 30 decibel difference. But you've no control over these guys, and these guys will see, well, I always want my window open at night for ventilation purposes when I sleep. So you're going to take a worst case scenario. We're just going to have 10 reduction for in there. Okay, so you're going to add up these 3 factors, because these are going to be reductions, these are minuses, so you're going to minus these from this value here, come up with a predicted sound level. So route 1, sorry I should have explained that, route 1 is here, is the outdoor patio. So route 1 we've got a value of 40 decibels, so that's pretty okay, it's below the 45, and that's at night. You know, who's going to use the patio necessarily at night? Property line, route 2, we're at 50, so that's probably going to be okay. And then we've got value inside the room, which is 32. That's sort of okay-ish, maybe, depending on which standard you look at. So, the Canadian Mortgage and Housing Corporation, very old document, hasn't been updated. They were suggesting that 35 inside a bedroom is okay. World Health Organization, new standard, they're suggesting 30. So 32 might be just a touch loud, so you might just want something a little bit quieter for that. Okay. In the standard itself, they've got nice little charts. So for each of those factors that we were looking at, so it talks you through the sound paths. So if it's outside, it's 0, in open window, 10. Single glazed window, they've said 17, okay. That's got a bit of a buffer factor, a safety margin in there, and for double glazed unit, they're looking at 20. So this is just telling you, as we said, if you're close to walls, if you're just close to one wall, you're going to add 3. If you're close to 2 walls, you're going to add 6. If you have 2 walls close together within 15 feet, you're going to add 6. So I'd get that standard and I know my sound power, I do those calculations, and then you're pretty much going to be fireproof if you get below the bylaw level.
Can you gain anything by putting sound absorption on your own building if the equipment is just off that wall?
Yes, you will get some reduction because you're passing through the fluffy material, hitting the solid and coming back, and so you're going to get absorption as it passes through. As a solution to a problem, no, I don't think the complainant's going to say, I want all this wall treating to solve the problem, thank you very much. They want the treatment at the source and not at the receiver. Generally, that's where you're going to try and do the treatment at the source.
I think what he meant was the reflection factor that you're calculating.
Oh, from
when
here?
you-
So
yeah.
if we covered all this wall with fluffy material?
Or enough of it anyway that you could then deduct that factor? Based on the chart of the effectiveness of the...
The standard doesn't give that as a solution. I think it would come down to, would your own client want something like that installed on their property? Probably not. Could you put enough of it on there to have an effect? Probably not. So unless you were making it as an enclosure, complete enclosure, I would say probably no.
Well, what about that acoustical fence and then have sound lining on that fence? Is that practical? Because I think this is a fairly realistic situation that we're facing.
Certainly, let me get the standard up completely. Let me just come out of this. Let me just do... okay. Forgive me, I'm doing okay for time, am I? You okay for...
Sure.
Yeah, okay.
That's okay.
So... okay, so you've got to, so if you're less than 5 meters in between, you've got to add 6. Okay, that's what that's saying. Let me go to the solution. So for barriers, you could use a building as a barrier. They work just as well as a fence.
Quite a bit more money to construct.
Yeah. No, but if you're in a site that has multiple buildings, you could look at the siding of it to position your unit where there's a building that isn't going to be disturbed by the sound in between.
Sure.
Okay.
Cheaper than $100,000 for legal fees.
I'm sure there's a little. Oh, maybe it's not that one. Hold on. It might be the Ontario guide that has it in. I bet I don't have the Ontario
Well,
guide.
maybe to rephrase the question, what would be the practical advice you could offer in a previous situation besides changing out for quieter equipment?
Did you see the distances though?
The
Did you
distances,
see the distances that were there that gave the 14 meters?
Yeah.
And you got you well under that 40 decibels. 14 meters is not a typical practical
That's
distance
pretty-
from a condenser on a property line. That's a large property, right?
That's a large property.
Yeah. I mean, city lots, you're not, at the side yard, you're not going to do it. I mean, and basically, maybe the message I should say is, tiny city lots, side yards, don't even think about it.
it's actually banned in Vancouver, isn't it?
There you go.
You can't go between buildings with
Yeah.
your condenser.
Yeah. And I mean, even if you're thinking about a wall barrier or an enclosure, depending on its size, you might need city permits for that. I mean, I'm not a city bylaw person, so I can't really speak, but my understanding is a fence can't be more than 6 feet high. And if it's near the street, it has to be even lower. And if you're putting a structure, depending on the height of the structure, you might need a permit and may not even get a permit. So enclosures can be problematic as well. So if you're going to build a barrier and you end up having that sort of canyon effect, certainly the reflections that go over the top of the barrier, to try and mitigate that, putting sound absorbing material on the source side of the barrier, it's definitely a thing to do. I just don't think that it would get enough reduction to you not having the penalty of the 3 in the calculation.
How about rooftops?
Rooftop.
Is that just now we're just broadcasting to the entire neighborhood?
Yes. So you do the same calculation. You do the same calculations, but it's maybe a little easier because you might be able to build a parapet wall. That might work for you. So if you look at one of these is, there we go. So in this example, it's not drawn very well. This is the ground. This is the building. This is a roof-mounted piece of equipment. This is somebody stood on the ground. So you've worked out that actually the corner works quite well as a barrier. If you're in a building and you've got your bedroom window here, it's not going to be so good.
But isn't
You've got-
the reduction in that case, though, in the case of a fence, though, if it's on the roof of the buildings are the same height, the window would be lower, it would be the inverse of that fence as a shield, would it not?
Absolutely. So let's see if we've got, and there you have. Okay, so there's the ground, there's the roof, then we build a parapet wall. So I guess if your bedroom window's there, you're getting some barrier effect. Now to calculate how that works, what you do is you take this length, so from the source to the top of the barrier is length 1, and from the top of the barrier to the receiver is length 2, and then the straight line from the receiver back to the source is D, and then, let me go back to the front, you do a little ratio calculation and that will tell you what your reduction is. So L is L1 plus L2 minus D, and then whatever that L value is, there's a sliding scale, so if the L value is small, that means that that triangle is very tiny, and so you don't get much reduction. If that triangle gets bigger, this space gets broader, then your reduction gets better. So this is what this is just telling you there. Okay, so you'd have to do the math. So it looks as though you're getting anything from between 4 decibel and 17 decibel, depending on that factor. I think it's certainly worth getting hold of a copy of that if you don't already have it. And it'll help you, I think, when you're out on site.
Any other questions? David, you want to say
Back to
something?
your earlier question, you had 45 with equipment, 55 from the ambient from the highway side.
Yeah.
So it's clearly the highway dominated, so in the day it was no deal. What
Yeah.
about at night? Was the 45 acceptable?
45 in all the bylaws that I've looked at, 45 at night is or below is acceptable. Yes. It's only when it exceeds 45 does it then breach the bylaw. If it has a specified value in the bylaw, I can't speak to the general bylaws that have the general clause, which says anything that tends to disturb the peace, quiet, rest, enjoyment. The decision maker will make the decision as to whether that's been breached or not. And so I can't speak to that because I wouldn't be the decision maker. None of the bylaws that I enforce are written that way, but there are lots of bylaws out there. So for curriculums is one that's written as just the general clause. There's lots of bylaws that are just the general clause. So you would have to talk to the municipality and the decision maker that's making the decision. They may or may not have any acoustics training. They may or may not take any noise readings. But they will be making the decision. And forgive me, I can't say anything more than that.
We've run into scenarios where they look at the DB rating of the equipment, the published DB rating, and make a decision on that and make no site installation parameters as part of their decision making.
Okay.
So that might be one of those people you're referring to, or not, or maybe.
I mean, I think for you guys, I think the main thing is know what the manufacturer says on the sound power. Get yourself this, and then make sure that you're below the 45. Because if you look at even the general clause in the court, they were saying, even if the bylaw is silent on it, the courts are sort of saying, we're going to look out what the general standard is, and if the general standard is 45, we're going to hold you to that, even if, you know. So, sorry.
So, I am a bylaw officer.
Okay.
I do take noise reading.
Great.
And when you say AC, I'm also assuming that you may heat pumps as well, because they're
Yep.
AC units. I've not yet found a heat pump that is 45 or below.
Okay.
So, I don't know if they exist.
They don't.
And if they do, the ones that I've tested, they do not meet that 45 threshold.
Right.
And 45 is pretty low. Like, talking is about 60. If I were to measure what I'm talking at, is about somewhere in the 60s.
Yep.
So 45 is quite low, and I don't know if you've encountered any systems that are at 45, but I've not yet.
There are none.
Okay.
There are none, and the RI rating is tested at 5 feet, so the distance and all these formulas you're saying here are critical, and that the further distance you go, so that 74 or 72 is published based on 5 feet from the unit, based on a perfectly acoustical environment. So the published rating of that equipment, I find that 275, I didn't know 275 existed,
Right.
is perfect, because you do have to calculate all these other things to really get that true dB
Yeah.
rating at the
At the-
window or
Yeah.
the source you're measuring.
Yeah.
So,
So our bylaw does, it's from the property line.
Okay.
And we don't currently have any restriction on where they can put the units.
Right.
But when they're installed, I get the complaints.
Yeah.
And it's from the neighbor, and it's exactly what you say, is the bedroom window that's right below
Yeah.
where, or the patio.
Yeah.
And the homeowner is, we've suggested the blankets, the sound pads, the fence, but it ultimately really doesn't make.
No, I mean, in those situations, yeah, I mean, it's, I'm loath to say because I can't say what the performance of an enclosure would be, but if you're in that such a constrained site that there's no other place to put it, then you're probably looking at an enclosure. But enclosures are very expensive, and they may only give you 10 decibels, which if you're still at, if you're over 55, 10 decibels isn't going to get you down to 45. And if you can spend a lot of money on enclosures. But yeah, it isn't easy. I have to say, on the ones that I've measured that are over the 45 that have been inside yards in North Van, they've had to move the unit into the backyard and put a barrier in place. And then I've measured, and I've been measuring at patios and bedrooms, not at the property line, because if I measured at the property line, they'd still be over, because I'm just right on top of the fan. But at the bedroom windows and at the patio, then I've got them below 45. But they've had to move out of the side yard. I haven't found it practicable to be able to do it in a side yard. If it's a tiny city lot and both properties are at the minimum setback from the property line, I can't see how you can do it.
I think in Langley, they only allow the units in the front yard,
Right.
which aesthetically doesn't matter, because I feel that's what I got.
Is that right, Pam?
What's that?
I haven't heard that.
You can put it in the backyard too.
Yeah.
But city
Just can't be in the side yard, but
City or municipality.
front yard, to be honest with you, the front yard's the best place for it, because your typical vehicle is 80 plus decibels sitting in a driveway, and aside from the aesthetic
challenges, there's landscaping and stuff like that, but it's the ideal location, and it is the one location that's universally banned in Vancouver for a condenser location without any kind of, the bylaw officer couldn't even tell me why.
Yeah, in West Vancouver, we can't be past any setback of the house. So the side yard setback, what the house is built at, cannot have an air conditioner in the side yard. That's what I know. So whatever the setback is, you have to be beyond that.
You're talking setback from the street?
No setback from the side yard.
Sides.
Sides.
Within the
Or the front or
foundation.
back, or the front or back. You can't be up beyond the setbacks. Unless they got certain areas like Shahali has got different rules there.
So it basically forces you to the backyard, is that what you're saying? What percentage of what you go out do you reject? Is it a pretty high rejection ratio?
It's probably, I mean, I get, the referrals to me are usually where it's a problem. So
if
it's
see
hard,
you,
it's
we
hard,
want like that.
yes. So it's hard for me to judge that because the vast majority of the cases that I get are the ones that the municipality haven't been able to resolve with their bylaw officers, and then they're calling me in to do noise readings because they're contemplating they're going to have to go somewhere further with it. So I disproportionately see the worst cases. So all the good work that the installers are doing, I don't see, you know.
Yeah, it's all good. Are you all done?
I'm all done. If you
Any more questions for anybody? I just got told by the big boss here.
we're all the time. I've been in the shed for okay.
Russ, I'll just make one comment. On your early slide, you showed the spike in 2008, 2009 on the complaints to mechanical noise.
Yeah.
It was also when Live-Smart grants came out offering a $1,500 grant for people to go to heat pumps, and there was a sudden spike of a lower mainland furnace-only market with the odd air conditioner to everybody putting in heat pumps,
Okay.
to the shock of the neighborhood dealing with suddenly all these heat pumps that are going in. And I would probably safely, comfortably say that that equation or that
Yeah.
spike in 2008 was directly related to that.
Or the municipalities with lack of bylaws, they had to adapt very quickly. Side yard, so.
Reversing balance.
Anyways, I think we'll wind it up. Anybody have more questions? John will gladly ask you
Yeah.
afterwards.
I just want to say too, that you can see that we're making this presentation, and we'll be sending it to all spectrum members, and if you're not a member and would like a copy, just let me know.
Okay, thank you very much, John. That's good.
Okay.
That's great.